Good morning to all. So myself D Mahamitra. So I'm going to present a topic related to the subject name called Rehabilitation by Heritage Restoration. This subject is belongs to third year under 2021 regulation. So next we are going to the second unit. The unit name is Strength and Durability of Concrete. So in this unit, it consists of the following topics such as quality assurance for concrete, strength and durability of concrete, cracks, different types, causes, effects due to climate, temperature, sustained elevated temperature, and corrosion. So these are the following topics are covering under the unit number 2. That is chapter 2 consists of these type of topics. So first we are going into the introduction of this chapter, that is introduction to strength and durability of concrete. So here concrete is defined as high strength concrete on the basis of compressive strength measured at given age. So when you go for concrete, so it can be determined only by its strength, only by its high strength, that is. So next in the year of 1970s, so any concrete mixture, so any type of concrete which shows about 40 MPa, that is megapascal. Though so MP is nothing but it is a unit of pressure. It is having the more compressive strength at 28 days. So it is designed as high strength concrete. And later 60 to 100 megapascal concrete mixtures were commercially developed, and it was used in construction of like high-rise buildings, long span bridges in many parts of the world. So this term consists of the strength and durability of concrete. So we are going to the first topic, quality assurance for concrete. So what do you mean by the term quality? So always we know that quality means excellence. So here the quality control of construction, concrete construction, it will be involving two steps. The first step is material will be having the desired characteristics. It should have that durability, serviceability, safety, and aesthetics. And second one, the structure constructed should have good performance. So these are the 2 points to be considered first during the quality assurance. Next, quality assurance in construction activities guides the use of correct structural design. We have to see that the material which you are using for construction is having the correct design and correct specifications and proper materials. So this will be ensuring the quality of workmanship of the contractor, and it can be achieved finally by maintaining the structure after the construction is complete through specific periodic assessment for maintenance and repair. So, quality assurance is to provide adequate confidence that a structure or system or component will perform satisfactorily and conform with project requirements. Obviously, quality can be achieved when preventable mistakes are avoided in first instance. Serious measures must be taken to minimize the risk of managerial and communication problem. That is basic concept of quality assurance. So here they are telling that whatever the type of material we are using, it should perform satisfactorily to the project. So what project we are considering, anything of a building or any apartment. So for any type of project, it should adapt to that project. So we have to uh, check the quality whether it is fitted to that project or not. So that is called as quality assurance. So before quality assurance can be practiced, an organization has to be constituted and maintain a quality management system in its day-to-day operation. A quality system contains a set documented procedure for different process carried out by organization. In short, assurance is oriented towards prevention of quality shortcoming. It also aims at minimizing the risk of making mistake in the first place, therefore avoiding the necessity for rework, repair, or reject. So generally here quality assurance, it is called as a plant system. So that is the thing they have explained here, and it is a plant system of management which increases the level of confidence that a service of material will conform to specify established requirements. So for selecting a system of procedures, the level of quality should be identified, and then which type of material can be adopted, that can be identified easily, so that only you can avoid the repair works or reject works, etc. So the purpose of quality assurance is to provide assurance to client that standard of workmanship within the contract's premises of highest level of quality, and also the products leaving the industry is above a certain minimum level of specification. The construction industry has been struggling with the implementation of quality assurance for many years. The cost could potentially be reduced reasonably if the industry were hold on to the concept of quality assurance with the use of great success by me other than companies. So here, what is the necessity of quality assurance? What is why it is necessary in the sense? First point is quality assurance is necessary to give good performance and appearance throughout its intended life. We have to give a good quality material throughout the life. That is the first point. And second point, it is useful for promoting the quality schemes by engineers and designers depend upon for its reputation and professional failure to appearance. So these are the two necessity of quality assurance. And next, coming to the topic called behavior of concrete in extreme climate. So first one, it will be including the durability of concrete. So the concrete that withstand the condition for it has designed without deterioration over a period of years, said to be durable associated with volume changes. So it will be including for long time concrete considerable durable, and concrete is now used in high hostile and harsh condition, premature failures of many structures, and strength was the only one criteria in mixed design procedure, and use of even high strength concrete in aggressive environment has led to disastrous consequences. In addition to strength exposure condition, important consideration for durability, strength and durability to be considered at each stage, that is design stage. So here, what they are telling is first, long for long time concrete considerable durable, which means the material which we are using should have long lifespan. That is, lifespan should be more. So that is the first point. That is, the concrete material should have more life. Next, second point is it's now used in highly hostile and harsh condition. So even if any type of an disaster, if any type of an damages may occur, at the time it should withstand the disasters, that is due to natural calamities or due to any other type of disaster may come. So at that time it should withstand its capacity, it should hold its capacity, it should withstand its during its harsh climatic conditions also. Next one, premature failure of many structures. So it may having premature failures that should be avoided. And strength was the only criteria in mixed design procedure. So strength is the only term which is used in the whole of the topic. That is, it should have more strength. The next one is use of even high concrete and aggressive environment has led to disaster consequences. In addition to strength exposure condition, strength and durability to be considered. So in addition to that, you have to consider both strength and durability of that material. So what they're telling is the most severe climatic attack on concrete occurs when concrete containing moisture is subjected to cycles of freezing and thawing. So that is the thing which is explained in durability of concrete. So next one is factors affecting durability. So the lack of durability may be caused either by the environment to which concrete is exposed to. So which type of an environment in which the concrete is exposed, which may be of external causes such as physical, chemical, or mechanical. So these may be due to weathering, occurrence of extreme temperatures, abrasion, attack of natural or industrial liquids and gases. So these are the types of factors which affecting the durability. So the internal causes of this are alkali aggregate reaction, volume changes due to differences in thermal properties of aggregate and cement paste, permeability, vulnerability of concrete to external agencies due to permeability of concrete. Permeability is therefore of critical interest. Hence, for the concrete to be durable, it has to be impervious in nature. So first property is permeability. So permeability in which liquids or gases can travel through concrete. That is porosity. That is traveling into the, for example, if the stone has pores, so inside the pores the water will get enter into the stone as permeability. So that is an example of permeability. So here the liquid or gases should enter into the concrete. So that is called as permeability. So next, permeability affects the durability of concrete. Important bearing on vulnerability of concrete to frost. Permeability of concrete is also of interest in relation to water tightness of liquid, retaining structure and to chemical attack. The permeability of concrete is not a simple function of its porosity, but it depends on size, distribution, and continuity of the pores. Thus, although cement gel has a porosity of 28%, its permeability is only about 7 to 10 to the power minus 16 meter per second. So, as I said before, it should have some pores. So, pores is called as holes, so that only the liquid will enter into the stone. So similarly, the permeability of the concrete will depends upon the size and distribution of the pores. So the range is about 7 into 10 to the power 16 meter per second, and the porosity range should be about 28%. This is due to the fact that gel pores are so small that hardly any water can pass through under normal condition. The permeability of gel is 1 bar 100 of centimeters. Therefore, permeability of cement paste is controlled by capillary porosity, not by gel pores. Thus, the water's W bar C ratio is the main factor contributing to the permeability of concrete, and lower water bar cement ratio. Not only the capillary pores are less, but the diameter also less. The permeability of the cement paste, it is explained in the next figure. So this is the permeability of cement paste with the progress of hydration. So with the progress of hydration, permeability decreases rapidly. So when go for hydration in the sense adding of water. So dehydration in the sense reduction of water. Here they are adding of water. So here adding of water, the permeability will be decreases rapidly. So permeability is decreased in this graphical representation, and this is the schematic diagram of porosity, which is having high permeability and low permeability. So this graphical representation will be telling about the high hydration will be decreasing the permeability of the structure rapidly. So this is the graphical representation you can see here. The next one, in a mature paste, permeability depends on size, shape, and concentration of gel particles. Large cavities due to water bar cement ratio more than 0.7 will not get filled up by gel but will remain as empty cavities. So, age days with respect to coefficient of permeability. If it is fresh, the coefficient is about 2 into 10 to the power minus 6. If it is 5 days of concrete, in the sense 4 into 10 to the power minus 10. If it is 6 days, 1 into 10 to the power minus 10. If it is 8 days, 4 into 10 to the power minus 11. If it is 13 days, 5 into 10 to the power minus 12. If it is 24 days, 1 into 10 to the power minus 12. Hence, the ultimate value is 6 into 10 to the power minus 13. So, this is the coefficient of permeability. It is interesting to note that permeability of paste with low water bar cement ratio can be compared to permeability of dense rocks. Cement paste with water bar cement ratio of 0.71 is impermeable as granite. So this is the two graphical representation for water bar cement ratio and capillary porosity percentage. So here comparison between permeability of rocks and cement paste. So dense trap, quartz, diorite, marble, and again another marble, granite, sandstone. Granite is everything. These are the types of rocks with coefficient of permeability is represented here. Also with water bar cement ratio. And but it is noticed that mortar and concrete exhibit appreciably permeability much higher than the value shown in table. Highest permeability of concrete and actual structure is due to the following reasons. So formation of micro cracks, cracks generated during structural stresses is an important point. That's why I have highlighted. And rupture of interface between aggregated and paste due to volume changes. And coarse cement tends to produce paste with higher porosity. And according to ACE standards, structural concrete to be watertight. Water per cement ratio should not exceed 0.48, and use of pozzolanic materials in optimal proportion reduces the permeability of concrete. So this is the hydration reaction, that is calcium sulfate plus water will give rise to calcium hydroxide. So this is the hydration reaction will be taking place inside the water cement ratio. Thank you.